Welcome, welcome, welcome. It looks as though we may be able to do a stream now. Will it catch? Will it catch? Will it update? Will it update? Not sure yet. Just waiting for the stream to settle. It just came up with a message then, is video buffering? Well, on my side it is. Low latency under advanced. Okay. Are we up now? Are we stable? No. Okay, this is not helping. Okay, I've gone and done that. How are we doing now? Advanced. Disable that. Okay, I've done that. Done what it's told me to. It's buffering. Okay. Well, whilst my video buffers, and buffers, and buffers, I'll try and get as much as I can going here. Welcome, welcome, welcome to Amberskies. And this is C++ game programming with blades. That's me, by the way. Amberskies, yes. This video is brought to you by Amberskies. It's the future of 3D on networks. So let's see if this goes okay. And this stream seems to be buffering a lot for some reason. Okay. I'll turn it off there. Let's bring it up on our main screen and find out what we've got going on here, shall we? We have got Twitch. Hello, Twitch. Channel live. Looks okay. Channel live is okay. Yes, we're up, we're going. Okay. Let's get some programming started, shall we, eh? I think I've messed around enough now. Having problems with my... oh, there goes my buffer signal. Output's the same. Advanced. Advanced. That's looking fine. dashboard. And pop you out, please. That means I can get rid of you now and just watch it on the preview. Thank you. There's the preview. Preview looks live. Okay. Okay. I switched off, switched on some buffering. There we go. That's all I've done. So chat will be now a little bit behind what I'm talking about. So if you use the chat, there's a delay. My apologies, but it didn't look stable at all. Interesting. Here we are. We have. We have shader programs. Yay. Yesterday we completed shader programs. Awesome. Awesome. I'm so happy, actually. I know it's only a simple shader and it's rubbish, but hey-ho. What have I done with these thingies here? Here we go. There we go. Some tangle wires. And let's go to work. Yeah, we have a shader program. Right, let's get going on this shader program, shall we? I had left myself a note. A big note. Note, this must be a class to work because we couldn't do the last bit. Well, that's correct. It does need to be a class to work, but in C++, there's two ways of doing a class. You can use either class or struct, and on the Windows 3D, we used a class. So this time, I'm going to show you how to use a struct instead. So we can take that note off for starters. We don't need that. The struct itself, we will keep within GLSL, or do we want to keep it within game? I want to keep it within GLSL. Okay. So my video playback right now is rough to tumbling, it looks like. With 2 viewers. Hello, people. I'll say something in chat. Welcome. Come to... I can't type yet. There you go. Oh, look, there's a chat thingy there. What I'm going to do is turn this into a class without altering anything. That's cool, isn't it? Yeah, I bet you didn't know you could do that in C++. I bet you thought it was all going to be dead fiddly. Where's my coffee? With this stream buffering thingy, I'm not really happy, actually. I don't like it doing this. I prefer more interaction. Oh, well, I'll leave it like this for this episode. I think that's only fair. Let's see, how can we do this then? Let's go here. I'm going to keep it in GLSL. So what I'm going to do is create a class. There we go, like I said, we needed to. The class is going to be shader data. There we go. That's our struct. There we go. That's our class. Our class is going to contain the following. It's going to contain, let's see, a gluint, program ID. Can I use a gluint at this point? I can't, can I? Oh, yes, I can. It's me being a muppet. There we go. Gluint. We'll have program ID. We will have a GL uint, and this will be vertex shader. So vertex shader ID, and we'll have a GL uint, and this will be the fragment shader ID. Okay, are we alright with that? Now the beauty of a struct is that everything's public. So do I need to do a constructor and a destructor? No. They're automatically produced by the compiler, but do I actually need to do that? Nope. Not at all. So let's just switch that off because it's annoying me. I'll watch my. I can see from my stream stats that there's no problem. It's just my trying to display it seems to be a problem. So I'll stop that. So there you go. I've turned it into a class. Wasn't that easy? So now, what we can do is we can produce a struct. So here, it isn't unsigned data anymore. We can have shader data. Yeah. There you go. So now we can have shader data. We have to have that in shader CPP as well. There we go. It tells them where the error is. There we go. We can have shader data there. And if you have a look down here, a return 0. So what we're going to do is we are going to make a new shader data at the top. And this is going to be called shader data. And that's just going to be called data for this purpose. And that is going to be a storage for the GFX card IDs. Okay, so we now have a data. So what I can do is I can now store data. So if it equals 0, returns failed. So what we need to do here, actually we should really have a constructor, shouldn't we? And we should be explicit about it. Actually, no, we don't need to. Just realised. We can do that. That's naughty of me. I don't care. Instead of using a constructor. Yeah, that'll work. Okay, so I've got it working now. That's okay. So after return 0, we just return data. Yeah, that's now working. And after that line, because it'll still be 0 at this point, after this we can now not do that. That's silly of me. We can now put data dot, and this is vertex shader, isn't it? 0. Blah 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 blah. Just make sure. Vert, yeah. There we go. It's here. It's this one here, isn't it? So what's the first one for? Let's read. Come on, Blaze, let's read. This is why I need these notes. Loads and stores our data. Returns error false. Full name of file path for the shader. That loads the shader. Loads and stores our data. So I don't need... That's a check for it. That's not needed here. Cut. Sorry, my bad. Compiles the shader, returns 0 if failed. So shader ID equals create shader. Otherwise, it returns a shader ID. So if it equals 0, return data. Otherwise, we can do that. Equals shader ID 0. All we have to do is put it in the right place. So now we just store ID for the return values. This is how to make multiple return values, really. So now we clear, then we load the fragment. We check whether the fragment shader is working or not. If it isn't, it's 0, which is okay. And then we try and create the shader, and if it fails, it's 0, which is okay. Because we've got 0 for it. And if that's okay, then we're alright. Just pop that there, pop that there. Lovely. So all we do here is exactly the same. We put data dot fragment shader ID equals shader ID 1. And that does the same as the first one. There we go. Now we go through all of the program here and we look for return values. There's one. Just return data. Simple so far. Looking good. Looking good. Yeah, that's okay. That's alright there. If error, still return data. Otherwise, what we do here, instead of return program ID, what we do is we put our data dot program ID equal to program ID, which is interesting, like that, and we just return the data. There we go. That works perfectly. So we've just made it into a class, because data is going to be our class. What that means here is that we need a data, and I just placed it where? Game, GLSL, shader data. Yeah. So how we write this now is totally different. What we do is we give ourselves a data. So here we would do game, colon, colon, GLSL, colon, colon, shader data. And we would, what can we call that? Normally it would be M, but we can't use that. So I'm just going to call it shader data. I don't care. And now that is, hello, shader data equals that lot. Lovely. That works now, because now we have a complete storage of everything, which is what we really needed. Paste shader data dot program ID. There you go, that's how we use it. So that is rewritten as the original test, but now what we can do is we can write our final shaded bit. So let's just get rid of you, shall we? We can write our final function. Yay! Because if you remember, I had to stop because we needed everything there. But now all we need is shader data, and that will give us everything. So now we just need a shader data, and we can call it data. Like that. Just need the address of it, don't I? Yep. I don't need the full thing, because I'm already copying it once. I'm not going to copy it back again. I know it's only 3 integers, but there you go. That is now correct. I can do that. And it's now correct. It's now gone green squigglies. Isn't that hilarious? I find that absolutely hilarious. You can write C++ this way. I find it really, really good. So let's just position that to there, and we'll just do our green squigglies. Create definition, and there we go. That's it. Why have I got all this space all of a sudden? Don't know. Save. Fantastic. Save. Fantastic. Let's go write it. It's pretty easy, really. So, what can we do? Are we going to have to do this backwards or forwards or sideways? Right, what we need to do is, first of all, issue a command which says GL, and it's going to be use program, because we can't do anything, we can't delete anything if it's in use. It won't let us. So we're going to have to stop it from using, so we'll send it to 0. There we go, that's our first command. And what this does is this tells our GFX card which shader program to use. And I can put comma 0 equals none. No program. Which is exactly what it does mean. And that tells, actually, the value 0 equals use no programs. Right, so I can get rid of that off there now because I'll put it on the next line. Now that's correct, yeah. I'm happy about that now. So that's how we're going to start that. We're going to start by saying, hey, GFX card, stop using all programs, we're shutting down. We then need, this is funny, Will this cause an error if I try and detach an unattached shader? Yes, it will. So, next step, if data dot program ID is not equal to 0, because remember 0 is false, or, well, actually 0 is false, isn't it? Oh, I'll put it in full. Then we detach the shaders. Yes. The shaders are in the program. The program owns the shaders. We have to untangle the OpenGL web, as it were. We have to switch everything off. All the switches are on at the moment, so we better do this. Detach shader. There it is. And to do that, we just need a glue-int shader. That's handy. So I can just put in data dot, and we have a glue-int shader. We'll do the vertex one first. And that's really it. Does it need something else? Too few arguments in function call. Ah, yes, it doesn't know which program, does it? Sorry, my bad. Data dot program ID. Whoops. Helps if you give it that. It needs to know which program ID. Yeah, okay, comma. That's better. That's better. Thank you. Sorry about that. All we do now is repeat it. Paste. There we go. And instead of the vertex shader, what we're going to use now, believe it or not, is a fragment shader. So we have to do it for both. So what we're doing is we're now detaching the shaders from, we're unraveling, we're unknitting, picking out the stitches, switching the ons to offs, really, is what we're doing. So we can detach the shaders. We can also delete them. But I want to know if they exist. So, well, the condition may be that they exist without actually be part of the program, if you remember. They might not. In the previous program here, we keep returning out with data, which means the zeros. So if we've done that, it hasn't got that far, but they still could be created. So you could create both shaders, and it could fail and have an error on the actual program ID. So we could still have shaders at this point without a program ID. So program ID could equal 0. So we have to come out of the if statement, and we now have to put if. And this time we are going to ask for data dot, which one should we do next? We have to do it backwards. So it's fragment shader was the next one. Fragment shader is not equal to 0. I'm doing it backwards because you really should. So if it isn't, which obviously it will go into this part naturally, even if you detach them. Whether you detach them or not doesn't affect whether it actually exists or not. So there's no knock-on effects going here. So now what I'm going to do is, oh wait a minute, if I've detached them I can actually delete the program ID, can't I? Sorry, my bad. So we do have an extra step we can do here. GL. Once the shaders are off, we can delete program. There we go. Delete the program. and that just takes a program ID. So, oh dear, Muppet. Coffee, thank you for reminding me. Coffee's going cold. Wow. So I'll do that. That might help. That will help a lot if we delete the program. Because what we're looking to do now is delete the shaders, aren't we? So, yeah, we've got that far. All we need to do now is delete shaders and that's it. Fantastic. GL delete. Yeah, okay. And if I put SH in, it'll give it to me. Yeah, there we go. GL delete shader, and you can guess what's coming up now, can't you? Data dot fragment shader ID. That's that one done. And the last if, remember they could all be 0. It might not have even got past the first bit of data, but we have to do this. We have to check data, because if we don't check, we won't clear it, will we? Vertex shader ID. And that not equal to 0. Let me just clean this up before I forget. So there we go. We now can GL delete shader, open brackets, and of course that will be data dot vertex shader ID, and that's the way you should really do it. Check that it exists, and if it exists, delete it. If it doesn't, it'll go straight through this program. If none of it exists, if the whole thing failed, then it just wouldn't do anything except shut down the usage of the program, which wouldn't be in use anyway, so and that doesn't create an error if you duplicate it, so that's okay. And that's your deletions. So you've got your shape, you've got your vertex, your fragment, and your program all deleted. Now, this doesn't know whether they've been created. Well, whether they've been created or not is irrelevant because we've used if statements. So that's now void shader shut down. That's now done. Fantastic. Completed the shaders now. That's it, complete. Done, done, done. Which means back in our game, what we do after we've finished, we just run that program, which will be game colon colon GLSL colon colon, and it will be shader shutdown tab open chink, and it will be shader data, is it? Yeah. We called it shader data. Yeah, thank you for that. And there you go. That will now shut down properly without messing my graphics card up. So it is no longer a test. It is a fact. So we can take the test thingamajiggies off. Okay. And we can write this properly. There we go. I'm going to keep the printf in because I want to know more information as possible. Now, what haven't we done? Shader H is complete, is it? Yep, that's complete. There you go. It does what it says on the tin. Down to the bottom. Let's start filling in notes. There we go. And we are up to here. One more, please. Right, let me just finish this coffee. Now you know why I needed all those notes. Otherwise I put things in the wrong place and it won't work. So let's do this properly, shall we? Copy you. If you get ahead of yourself in this programming game, I can tell you now, things fall apart very, very quickly. Return the open GL IDs as a struct. There we go, so that returns data. That's okay. Happy with that. Check if, let's start again, let's do it properly. Check if we have a shader program. And if we do, what does detach shader actually do? Okay, remove shader from the program. And that requires the program's ID, OpenGL ID, come on, do it properly. OpenGL ID, and that is, in this case, yeah, the shaders OpenGL ID. There we go. Which means, oh, I've still got this weird delay on right clicking. No idea why. And I am dropping frames. What on earth is going on? Oh well, I'll have to check this video afterwards. That's damned annoying. I hope you aren't missing much. Mind you, I'm going over this again, so yeah. That's the same. Muppet's nicely curled up on me, it's so sweet. Yes, as I'm just doing the notes. Delete the program. Removes the shader program from the GFX card, which is what we're after. And that's that one there. So that actually works out quite well. I'm glad they did it this way because it is really nice and easy. Okay. So copy that. Delete that. But you can see how easy it is now to expand this, because all you do is you can add more shaders here. If you want to use more shaders, you can detach more shaders at this point, and you can obviously check for more shaders using these simple if statements, just by putting if such and such exists, delete it. So it makes it very simple for the program to grow, and the amount of shaders that you use can grow very easily because you have a shutdown procedure now that you know works. And trust me, it does. I can't prove it, unfortunately, because once it's all deleted, there's nothing to prove from. Does that make sense? Right. Yeah. That removes the shader from the GFX card. That's right, and that's just one there. There we go. There we go. Simple stuff, nothing exciting, but worth doing. There we go. Copy you for the top one. And that's just a vertex shader. Shader, the shader's OpenGL ID. Yep. So I'm happy now. That's all noted properly. So people coming along can now add to this a lot easier. That is now complete. Never need to look at that again. That is now complete with our shader data. Never need to look at that. See, told you to turn it into a class. Didn't tell you how though, did I? Whoops, what have I just pressed? Don't know. Right, okay. Save. Okay. That one there. Did I give this a header? No, not really. Copy that bit. I think is going to be the best idea for that. It's no longer a test piece anyway. I can tell you that. There we go. That gets duplicated here. There we go. This creates a data storage struct for OpenGL shaders. Compile the complete shaders into a single program. Yeah, that's okay. And that is the name of the shader. This one's easy. That's output to the console. Formatted text to output. and that is the data we wish to output. There we go, that's that. And you're lying on me arm, Muppet. There we go, everything's now noted, everything's now fine, we can get on with our time, energy, and everything else. So we now have a full program that works. So if I run this now, it will delete the shaders. How do we check? You can't. I don't think there's a way of probing the GFX card OpenGL for that. Well, none that I can think of off the top of my head. If you do know, let me know. If you know there's a way of testing that, then that'd be fine. All I can really do is this, which is right at the bottom here, isn't it? Right at the bottom. All I can do really is that. Debug times 64, yeah, run. Compiling. Good. Any mistakes? Have I made any errors today? Yeah, I haven't drunk all my coffee. That's what I've done wrong. Okay. We're up and we're running. And we do have a shader program. It's not 0. Yeah. ID 1. Isn't that ludicrously informative? That's okay though. If we now shut down, it'll come to here. Here we go. And this will show me, hopefully, locals, data. There we go. Program ID is 1. The shader ID is 2. And that is ID is 3. And they're all unsigned ints. So there we go. That's your data. So it shows it correctly. 1, 2, and 3. Clever, huh? It's coming from line 62. I can pop that up. So it's actually, well, when it returns out, it comes from there, but it's coming from line 62, which is here at the end of the shader shutdown. That's correct. And we can step through it and make sure that everything works by using step over. So there we go. It goes in to delete, and it deletes, detaches, detach, delete. It then goes in and deletes the shader, and that's it. Return 0. And out. We completed the 0. There we go. That just shows you that it does go through it and that it does work. It's the only way I can do it. So if I run it without, what we're going to do is get, and I know it works because it comes up with shader ID 1 again instead of shader ID 2. If it doesn't close down properly and there is an error, then that'll probably come up with a silly number. So if I close down now, everything's hunky-dory and no problems here. Output exits with a code 0. Thank you. Error list. None. 0 warnings, 0 messages. I'm happy. We've got 0 going on that's bad. So what I want to do now is just check for warnings. You might think, but that's daft, Blade. No, it's not. Just going to rebuild it. So I saw a message. Come on. Give us a message. Jeez, why is that taking so long? Warning, link, PDB. Yeah, I know about that. We're going to have to live with that one. I mean, all that says is that the database for the debugger isn't available for glue32 static lib. Well, it's not my lib. I wasn't going to alter it anyway, and I'm not debugging it. So, I'll live with it. There we go. It's all succeeding. No silly things coming on. I don't like the way it just says generating code. Why doesn't it? I don't think I've got it switched on to show me what it's generating. I'll look into that after. I don't mind for now, because we've got a complete running program with shaders. So now where are we up to? That means we can do OpenGL. Let's add new folder and call it dun, da, 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 dun, da, da, OpenGL. Ding. Let's have rendering as a thing. So, new item. Header file. I'll call it a rendering. No, I'll just call it render. There you go, render.h. Isn't that easier? Slightly. And I'll also have a CPP for this. Do I really want a class for rendering? To render things to the screen, does it really need a class? There's a thought. Or is it just a simple process? You know, that's, yeah, but it's going to be called all the time. It's going to be used all the time. And we could store shaders in there, couldn't we? Yeah. That's interesting. Oh, this is starting to sound more interesting by the second. So I'll call it render again. And that's your CPP file, isn't it? Dot CPP, thank you. Oh, I'll take it from one of this. I'll take from shader.h. Doesn't matter where I take it from. And then it's hash include render .h. It's got a namespace of game, and it's got a namespace. Always double my namespaces up of OpenGL. Yeah, that's the directory I've put it in. If you might notice, I just have one overall, and then it's just a directory that I've put it in. It's a simple way of doing it. So I can now copy all of that. No, I can't. So I can copy all of that. And that goes into the header. I don't really want that there. And that becomes pragma once. There you go, it goes there. Are we happy with that? Yeah, I'm happy with that. Now, because it's rendering, it's going to be OpenGL based, I guess. So we will need the window. So I know that's a given. Hash include. What am I doing? I should have kept this open, shouldn't I? Do I need file handlers? No. So I can copy that straight over. There we go. That'll work. Okay. So renderer.h. What kind of things do we want to do in here? We want to render. Okay, let's do that. Render. Okay. What's it going to be responsible for? Our renderer. Is it going to be responsible for everything? Nothing? Something? Right, I'm just going to put void render scene. Like that. That's all I'm going to put. Okay. That's all I'm going to put for now. What's my problem with this? Here's the thing, I can write it as a function, and then I can probably decide. I'm going to need GLM. I think this is one of the problems that I'm having, is I'm really going to need GLM, aren't I? Yeah. What is happening to this stream? Have I got a preview anywhere that I can put up? It's looking awful. It really is looking awful. Not interested in what you got there. Create a dashboard. What have I got here? According to me, the stream looks okay. Okay, let's pop you out. Yeah, stream looks okay. I'll keep hold of you just in case. I'm hoping that it hasn't messed up all my work and you've missed everything. But I'll check the stream after. I'll check it over properly and find out if it's made a mess everywhere. That's okay. So what do we need for this? We're going to need GLM. What you do? Let's bring that back up again. As you can see, it's messing me about again. Stop messing me about. What is wrong with this? I can't get hold of it. GLM. Open GL Mathematics. Go here. And download it. Stable branch. I think that's... is there not a download on here? Right, okay. I guess it's just click on this button. Okay. How weird. How very, very weird this... I mean... I don't want that. Okay. Third-party SDK, yeah. Blah, blah, blah. Written in C++ officially, yeah. Here we go. You can click on these. So Apple, Intel, XE2. Oh, oh God. Visual C. I think that's the one I might have used for this setup. Probably clicked on that one. It might tell me. But what you use, click on one of these, and it'll give you GLM. If you're on Linux, you've already got it. it's in your repositories. You just download it through whatever you use, apt or whatever. I use Octopi on my Manjaro, and I just download it that way. And it comes through and it updates quite nicely. So let's have a look at my listings here. And workspace, all I've done is, oh yeah, I was trying to get Visual Studio Code to work again. Failed. So under Twitch, I've got game. Under game, I've got that lot. So under Twitch, we're alright. Under Thinking Club, we've got depths. And now, under include, I've just got a folder that says GLM. There you go. And it's got all this GLM stuff in it. Where is the Dubry? I didn't put that in, did I? Because I'm in Map It. Okay. I've got downloads here. GLM stable. GLM stable. Cut. I'll put it in depths. Doc. Here we go. Manual. Yeah, funny. Thank you. Thank you. I can now read it. Nearly. Yeah, that's better. Yeah, now we can read it. Good, 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 good. Right, this is a bit I want. That gives me perspective, translate, rotate. Okay, I'm just going to keep that open. Here. I can close. So now you know how I've set it up anyway. And this has got an include already into depths, so I didn't need to change anything in here. I've already got an include in there, so that's fine. I'm going to need rotation. I'm going to need that rotation. Perspective, translate, rotate. Well, perspective should be given by the window. Of all things. We shouldn't be dealing with perspective. So we'll give that maybe a skip. Translate and rotate and scale are all part of that. Okay, let's try it out and see if it'll work then. So hash include it puts a red underscore on a squiggly straight away, thank you. It's GLM, isn't it? So GLM, there it is. Fantastic. And I would like I would like map 4s, please. I'm just going to use map 4s. Map 4. I will also need vector 3s and vector 4s, won't I? At some point. Why is that wrong? What's wrong with my hash include? Yes, you can. Why can't you open it? Dumbo. There you go. Oh. Skip. Not found. Of course it's not found. Okay. Because I need to make it a .hpp. That's why. I knew I was stopping for a minute. For some reason or whatever. Now you can find it. Stop messing me about. Please say you can find it. You might not be able to, actually. Okay, let's try again. GLM. No. I don't like hash includes that just go red squiggly on me straight away. And it's GLM / what do we have here? Oh, we've got GLM HPP. We have map 4x4. We've got matrix. What vectors do we have? Oh, they'll come afterwards, won't they? Vex. Oh, we do have Vec3. Okay, we'll have Vec3. This is normally where I have my shaders open, isn't it? Not that one. That one. There we go. Vec 4 and Vec 3. Okay. And that will be VEC 4, please. We're going to need that. That's it. That's all I've got. I haven't got anything else. Fantastic. This is going to be an easy one then. Is that all we've got? Oh, okay. Yeah, what we're going to use for them then? We're going to need... Well, what do we need to render that? I wanted to use quads, didn't I, for terrain? So, shall we start with terrain? Yeah, I think that might be a good idea, because we've done this now. Graphics card shutdown and error checks. Again, we need a graphic... Oh god, we need another shutdown, don't we? We need rendering shutdown. Yeah, we do. And if we don't have that, that's going to be awkward. That's going to be damned awkward. Okay. So what I'm going to do is a render terrain with shutdown. That's what my aim is now. Introduce system startup and a system shutdown. Yeah, well that's obvious because we've now got a startup. That there from game display. From there to there is now our startup. Is it? No. From there to there is our startup. That's just info. So that's our startup file. I mean, I could call that initialize. As long as I passed back the window. And the shader data to be able to... Yeah, okay. Fine. We'll sort that out when it comes to it. Yeah, render terrain with shutdown. I think that's going to be the next part of the project. Yeah. So we're going to need some kind of terrain. Okay, we need that to be created. I only need, yeah, I need all the data. I want all the data because I want to change I want to change the fragment shader straight away. I don't want to be messing around with this code, C++ and OpenGL code, when it comes to doing the fragment shader, which will include light. Shut down, then introduce light. Yes. Because light to me is very, very, very important. It's what makes OpenGL so much better than sprites. I mean, I could have done this in sprites. I could just have started drawing little diddy sprites and making them hop around the screen. No, thank you. I like my OpenGL too much. So we're okay there. All right. That's what we have to think about. So go grab yourselves a cup of coffee whilst I look at this stream and go, what on earth are you on about? That we are dropping it. Not. It looks stable for me. Absolutely 100% stable, and we're already up to rendering. Oh my god. How can you render without a model? Of course you can. You can just render nothing. You won't see anything, by the way. Even if you render nothing. But you're saying, oh, blades, you're going backwards. Yeah, I always do. You'll find that out. Because then I know what I'm aiming towards. I put my goals down first, and then I program towards my goals. And if my goals aren't good enough, I change my goals. That's how you program, really. You don't program by starting with nothing and going towards something and hoping you get there. You start with something and you work your way backwards until you get it. Yeah, a little trick for you, a little hint, handy hint on programming. I want some terrain, so I need to be able to render it. So what do I need to know to render? Well, there's three things we're going to ignore, that's for starters. That's where the model is, where the view is, and where the projection is. We're going to ignore those because we aren't even using them in our position, a GL position. We're just taking the position as is. We'll have to modify that very quickly. Yeah, so it's going to be a very simple renderer. Okay, so let's have a look at what I'm ignoring. I'm ignoring a lot. I'm just going to leave it as that for now. I'm not going to put anything else in there. So here, I'm just going to note MVP. Doesn't mean anything to anybody, just a note. That's a note for me. So model, view, and projection. We'll ignore them. Light. I'm ignoring. Okay. So the first thing that we are going to do is bind our model. Yeah. Now, do we actually need any OpenGL in here? Not really. If you think about it, you don't actually need any OpenGL to render. There is another way of doing it. that would make it a class. We would need a render class. We'd have to take in all the information if we didn't give the information. The thing is, whatever information you can give at this point stays with the render scene. Any information that you need, like MVP and light... Oh, we need the model as well, don't we? Which we're ignoring, because we haven't got one. Stream seems stable. I don't know why it's telling me something. .6% on network for something or other. It's telling me I've got a bit rate of 5290. Oh, come on. Don't mess me about, will you? Alright, so we need a model. What else will we need? Nothing. Now, if it's terrain... Ah, no, we're going to have to use triangles. All our models are going to have to be in triangles. Because the OpenGL commands... Right, let's look at the OpenGL commands for a render. A straightforward render. What you have is GL bind, and it will have to be vertex array. Yep, that one. What does that take? A glueInt array. So we'll call that glueInt array. Didn't need anything else, did it? No. So that's that. Oh, can't use array. glueInt VAO. That'll do. Nice one. Yeah, I know I don't have a VAO. Get off me. Okay. So VAO equals... Sorry. So GLUINT VAO equals 1 for now. Not 0. That would then equal VAO. Like that. You can stop crying at me. Why are you crying at me? That's why you're crying at me. Right, so we've got the first instruction sorted, but we need a VAO. Any ideas where I'm going to get one of them from? Right, well I can make one of them quite easily. That's not a problem. Okay, so if we've got a VAO, we would then test for textures, which we haven't got yet. And we need to use the correct shaders. haven't even thought about shaders. We can get the shader straight away. I just need shader H, don't I? Yeah, I do. Game, you've got it. Oh, you're already up. That's you. Pop you in here. Yeah, so we can have that. Yeah, we need a dot dot dash on it. There we go. Thank you. You can find it now. Sure up. That will give us no. That will give us GLSL. Yep. Colon. Shader data. Just need a name for that now. Yeah, we'll have that. So here we go, we're constructing it now. Wait a minute. So we need a shader so that we can use it. That would help, wouldn't it? So we know how that works because we already used that command. So it was, what was it? GL use program, wasn't it? Yeah, I remember that. We just used it. And that just takes the glue int program. That's fine, because that is now in shader dot program. It's there. There we go, that's okay now. Alright, so we've got the shader. We can create a VAO easily. I've got a feeling we're going to take in a model. No, we're not. I'm not restricting this to one model. Okay. I could to start off with just for test purposes, but that would then make it awkward later on because I'd have to move it all. So once we've got a program, we've got an array, we've looked at textures, we're ignoring that lot. In other words, we haven't even got a model. What do we need here? We don't need much more. That's it. That's all there is. Here, it's just it's GL draw elements, please. There we go. And it's all of that lot. So what we got? GL triangles. I said we're going to be able to use triangles. So we'll pop that in. Count. That's how many indices, isn't it? So that's index count. What type is it? GL size I. Okay. Fine. Let's say GL size I index count equals, doesn't matter, 0 for now. Okay, we've got an index count. What else do we need? We need an enum type. GL unsigned. It's an index, so it's an unsigned int. That's okay. Do we need anything else? Yeah, where the data is. Oh no, it knows where the data is. It's in the element buffer. Index buffer. How does it know which index buffer? Const void star indices. Let me just put that to a null pointer for now. Right, so that's correct. Yeah, thank you. So that's how you draw. So I'm not happy with that. You can tell I'm not happy, can't you? Because I've hovered over it a little bit, and I'm really not happy with what I'm doing because I've just asked a question which I haven't got an answer for. We've bound the vertex array. That's for how it knows what data we're using. There we go. I've answered my question. So that is the open GLID for the data. That's the only way I can think it's going to work. Right, once we've done all of that, we then have to do a reverse. And we have to get rid of it all. Yeah, that's easy enough. Do it in reverse. So I would have another GL bind vertex array. Yeah. Vertex. This is, by the way, we're drawing nothing at the moment. As you can see, it says zeros. GL bind vertex array. We'd have to repeat that, but this time we would have to specify it that it's 0 and not put the word VAO in. And that zero equals clear the VAO. I think it, yeah, don't call it VAO. It's an object. Yeah. So that line binds it. Okay. Tells the open GL No, it tells us the graphics card. GFX card. Which data set to use? It's an array. It's a list. And it's a list of data buffers. So that's what a vertex array object really is. It's just a menu of data buffers. So you just list your data buffers down. Well, actually, it creates itself. It creates its own list, and I'll show you how to do that. It's just how you program it will create the list itself. So that's not a bad idea. Okay, we'll do that properly, but we've still got this gluse program here, and we know how to stop a program from being used. We just put gluse program and we put a 0 in again. So we're just zeroing things out really, aren't we? 0 equals clear the shader program. So zeros just mean basically clear everything. So if I was to run this now, it just wouldn't draw anything because there's nothing to draw. It all comes up as zeros, but it would work theoretically. Can I bind that? Can I build that? So these vectors aren't going to be used here, are they? No, they're not. I thought they would be. Because the data's all in that VAO. So what we need to now do is make them two items there. A VAO and an index count, which we can hold within a model. Let's call the model an entity. Yeah. Excellent. A plan is forming. You can hear it ticking away. And I just went red again. Why am I dropping frames? Stop it. I'm on broadband. I'm transmitting at 4,000 kilobits per second and it's dropping frames. Twitch, what are you doing to me? What on earth is going on? Okay, I'll watch this for a little while until it goes stable again. It goes green at 3,000. Okay. I could drop me video bitrate. Okay, dropping. The next drop down from that. Encoder hardware. Okay, let's apply that. Why was it on hardware? Who changed that? I didn't. How interesting. Never mind. Break over. Let's get on with this. Let's make some glue ints and some gel size eyes, and hopefully that Twitch will record this and we'll be safe. Right now I am not sure what the heck's going on, so I'm going to look it up. So just go and get yourself a cup of coffee whilst I mess about with Twitch. I do have another computer running here, so let's look up Twitch. There it is. Twitch. Let's have a look at what's going on here. It says I'm live. It looks clear. It's buffering. It looks clear. It's buffering. Oh no. What is going on? Twitch, you're letting me down. You are so letting me down. Why are you unable to stream? Okay, what's on my dashboard? Settings, channel. Is that something wrong? Not that I can think of. Live. Settings, advanced. That. That should work. Let's have a look what I've got on these settings here. I mean, the one that I'm looking at here is fine. But according to this, I'm getting absolute rubbish transmission of data. Wow. What is going on with the stream? Help. If anybody's got any ideas, just chuck it in chat. I don't know why the stream is so bad. I've got it set for... I usually have it set for like 5,000 bitrate. And I know I'm pushing 5,000 bitrate out. I've dropped it to 4,096. Okay. I really don't understand it. Everything's looking normal. Except for my bitrate. She's all over the place. Alright, so we're going to need a model. An entity. Let's OpenGL add. New item. We'll have a header file. Call it entity. This entity has to provide all of these numbers. That's going to be interesting. New item. CPP file. Entity. Okay. Copy that through. Copy it onto here. And that is hash include, and it'll be entity.h. That's you done. Oops, ouch. So, namespace. Game. Yep. And you're going to see something interesting now, because namespace is, guess what? OpenGL. You can have things in the same namespace. So it should be exactly the same as a renderer. Yep, exactly the same as a renderer. Fantastic. Pop an extra in there, take that lot. Copy. And that light stopped messing me about. I wonder if it's just on the receiving end. When I'm not doing much, it just drops the KBS and just pauses the frame on screen. Could be an interesting idea. Could be a very interesting idea. Yeah, right. I don't know. Twitch, Twitch, Twitch. You don't tell me how you work, so I haven't got a clue. Right. If we are going to have an entity, it is going to need to be constructed. It's a class. It's gonna have to be a class, is it? It can't just be a... No, it's a class. We need data storage. So it's class entity. Well, hey, we're gonna have a class. Hey. Sorry. I get excited every time we get to a class. I don't do very many of them, you see. Class. There we go. And 1, 2, public. We'll have you, and I think that's okay. And it will have some private stuff as well. So I know that already before I type it in, because I know it's going to do some calculations on the data that it stores. So, entity, what will it take in? It will take in a name. Wow, is that it? Yeah, that's it. And that's a doorbell. Just bear with me 1 second, my doorbell's going. Yay, medicines. More medicines. Take your tablets, Blades, you'll be alright. What was I up to? Oh yeah, I wanted to take in some information, didn't I, into my entity. That was the one. Oh, what we're going to have it as? We are going to have it as... I'm going to drop you for a bit because I don't like you being there. Game. What you got here? Not a lot. Okay. Don't want that anymore. Render. We've done rendering, haven't we? Yeah. Yeah, we've done the renderer. That's finished. Yeah, right. Does it build? Should do. Yep, builds. So we've got our renderer, right? I bet you never thought you'd see a renderer like that. Well, that's the truth of the matter. That's all there is to it. Alright, so the renderer's okay. Entity.h. I'm going to take in probably the same kind of thing that I did for shaders. Strings, vectors, OpenGL, core file handlers. Oh, I'll take you. That's all I'm going to take for now. Okay, let's set this up properly. So it's going to be private, yeah, that's right. std : string, and it's going to be name, m_name. No surprise there. Or title, name. I like name. And a public, we are going to have an entity, and it's going to take in an a const std : string and name. That's it. That'll do. And I will have a destructor for this. I've got a feeling, you know, in my waters. I've got a feeling in my waters that we're going to need a destructor, sir. So let's go back to this one. Create a definition. Yes, please. Just pop you to there. Don't know what I'm going to put in near that, so that's okay. Save. Done. And you to there. Create definition. Yep. Okay, that's looking good. Don't know again there, so that's good. Now, is there anything else I'm going to need? Yeah, there is. We are going to need to store. We're going to need window. Exactly the same reason why we needed window here. Just for the GL, OpenGL. If you don't include window, then it ain't going to happen. Because all our OpenGL stuff is in there. And in fact, that is going to actually give us one of the things we need as well. That's okay. That doesn't matter. Right, so the renderer, tell us what you needed. You needed those two. There we go. So those two have to be provided by this. So what's a VAO? That's your vertex array object. These are going to be member variables. So those are the two things that we are aiming to get out of our entity. Our entity has to be able to provide a VAO and an index count. And I can tell you what those are already. It's 1 and 4. Right, so let's create an entity. Do we need a return value from creating an entity? Not really. You can store all the information itself. So void create entity. What's it going to need to create it? God knows. No idea. So we'll pop you in there. I'm guessing we should really take the window in. Because at the moment it's not going to really create the entity, is it? It's just going to create a load of data in a VAO. Let's be honest. And the only two things that we really want to store are VAO and index count. Okay. Yeah, that's okay. I'll take that. Entity stores all the data required for a single model. I'm not happy with this. Why? Because the entity needs to be split down into different parts. I'm just looking forward into the future and the problems I'm causing. Okay, that's alright, that's okay. So this is member variable to store the entity's name. This is a member variable, and that is to store the OpenGL vertex array object, which I've already described to you as a list of buffers. And here, a member variable. Ooh, Freudian slip. Ooh, let's make them member variables, please. Member variables. That's what the M stands for. Variable. It means it's a member of the class. In other words, it's available to the whole class. To store the to store the number of, and it's indices. There we go. Sorry, I had to think. That is simple. That's a constructor. That is simple as that is a destructor, and symbol at the beginning there. At the beginning there, make it nice and big for you. It's called a title, or how did that American tilde? Is it American tilde, or is it British tilde and American title? Don't know, but that's what it is. Fair enough. So that's your destructor. Just so you know which key I pressed to get that squiggly line. For my keyboard, it was shift something. Shift hash next to the enter key. So that's that. And this we're going to use creates all the data needed for the model. That's what I'm going to do with it. It's wrong, but I don't care, because this is going to get chucked somewhere else. The entity isn't going to contain that at all. It's just going to probably contain position and rotation. Yeah, location, rotation, and scale is all an entity will eventually hold, and all of this will be done elsewhere, and the model will be pulled out from the entity and put into a model class. So what I'm really doing here is a model class. Should I name it model then? Really? Yeah. It's a model base class? No, I'm going to keep it as is, because I want it to be in my mind that this is for a model which is fine. An entity can be for a model as well. Doesn't have to be restricted. So, how do we create an entity? Well, what data did we have? That one there. So we have U3. U3, come with me. You're wanted. There we go. So that's what we have in our shader. So I will need positions, normals, and colours. So let's make some up. No, I mean it, seriously. Let's make some up. First thing I'm going to do then is just do that and that to stop it from annoying me. I don't know. GLM. I put it into the renderer thinking I was going to need it. Cut. Don't need it there yet, so let's get rid of it. We can get rid of the render altogether now. Let's concentrate more on this. H, shader, get lost. H, thank you. Space, V, thank you. This is what is it? How can I open GL maths library, and that will be a vector 3D. This, you're gonna laugh, is an open GL maths library, and that is, believe it or not, a vector 4 dimensions, or 4D. Yeah, we're going to use a 4-dimensional vector. Wow, but I can only see in 3Ds. Well, we just need to be able to, you know, do things. Don't worry. Don't worry about how many dimensions it is right now. The values won't impress you. They're all 1. We use a 4th dimension so we can rotate a 3D model on a 2D screen. Otherwise you can't, because our screens are 2-dimensional. Yeah. So GLM colon vec4. There it is. Vec4 positions. Yeah, just call them positions. Can do that, can't I? Equals this. Oh, sorry. Semicolon. What are we going to put in here? Let's put some numbers. I'm going to view this in the negative, so I just want something that's in X, Y. Now the centre of the screen is 0, 0, and we are at 0, 0, 0, 0, 0, 0, 0, wherever that is. We're at the middle of the universe. So I want it to start on plus X, no Y. So that's easy, isn't it? Oh, right, I can do that quite easily. And I've got to make it counterclockwise, have I? So that will be X is across. We'll go to 0.5 across. Actually, no. I'll have it on the right hand side of the screen. I'll have it all positive. So we're going to have the X as 1.0. That's your first bit, and it's f. My y's are all going to be at minus 0.5, so that we're not looking at it edge on, otherwise we won't see anything. Good mistake to make. What can we make the next one? X, Y, Z into the screen. It'll all have to be minus, so it's minus 3. Yeah, minus 3. And this is in meters, by the way. My head works in meters for this. And the last one's dead easy. It's 1.0f. I'm putting an F there. Am I not allowed to do that? So that's 1. No, it's 1, 2, 3, 4. How many vec4s am I going to need? 4, 6. Am I still not allowed to do this? Huh? Okay, GLM, how do you work? These are all floats. That works. GLM doesn't work that way. Okay. That's my position. No, this is going to be my positions data. So I'm going to need, that is going to be, a comma, I know, tab, // 0. Okay. Next, to make this counterclockwise, I've got to go into the screen. So everything is the same, just change the Z value. So it's 1.0f minus 0.5f. Yes, if your head works in 3 dimensions, this is easy. Sorry, 4 dimensions, yeah. And of course the 4th dimension will always be 1.0f. Don't worry about it. That's a comma. That's a 1. That's return. Now we need to come across and towards me, or do we stay away? We stay away. So the only thing we're going to do now is bring that back to 0.0f. And we can keep everything else the same. Minus 0.5f, comma, minus 4.0f, comma, 1.0f. This is how you draw a 3D object. These are all the points on the screen that I'm going to be joining up. Don't worry, you won't have to do this for a full model. We'll just read it off disk. It's easier. Okay, so that gets repeated. And that means the only other thing that we need now is 0.0f brought towards us by 1 meter. Yeah, so it's a 0.0f, comma, minus 0.5f. Remember I said GL triangles, minus 3.0f, comma, 1.0f. What we have now got, oh god, I didn't put it in, did I? Is 4 locations in space, 4 dots. And we're going to play join the dots, especially if you can put commas in properly. There we go, that's positions. Normals, Is going to be y equals 1. That's easy. Float normals equals let's see, x, it won't have anything. Y will be 1. Positive, yeah. I want that one going upwards. And 0. Because this is a vector, it's not a point in space. So it's a vector of 1 straight upwards. And it's 3. Vec 3, isn't it? Yeah, good. And that's a comma. That will be 0. And it's the same for all of them. Take off the last comma because I like to be tidy. Oh, the normals are always easy. Semicolon, yeah, that might help. What do we need next? Colour. Oh god, what colour are we going to make this? Let's be fanciful, shall we? Colour. Equals. What should we make our colours look like? 0.0f, comma, 0.0f, comma, 0.0f. There's 4 we've got 4 on this, haven't we? So the last one is 1.0 f. We'll have our colour solid. That means solid. That means in the 4th dimension we can rotate them around that point. That means that the colour is solid. So the last number can actually mean different things. Be careful. Be careful with that. We're using 1, by the way, so we can rotate at a distance of 1, which makes all our calculations very easy, because 1 is a nice number when using calculations. So I'll just copy you. Yeah. Control V, Control V, Control V. I haven't put the commas on, and I haven't put the dashes on. 0, 1, 2. And you're going to find out why I'm putting the dashes on now. 3. Thank you. All of those match up. Okay, 1, 2, 3, 1, 2, 3, 1, 2, 3. So our index is GLUint index equals, wrong way round, doesn't help, does it? Okay, why can't the index be a GLUint? Error type, okay. Are you happier with that? I'll look at you in a minute. Right, it's going to be 0, comma, 1, comma, 2. That's 3 of these. 0, 1, 2, and 3 make a triangle. And now 2, 3, 0 also make a triangle. So you repeat the first one, 2, You then go to the one you haven't used, 3, and then you go back to the very start, 0. So that's 0, 1, 2, 2, 3, 0. That's right. And that's your indices, or your index, and I bet that can be a glue int. There's nothing wrong with that, is there? No, it was just messing me about. I don't know why it was messing me about, but that's all your data that you need to draw my first piece of terrain. And that sharp claws in my leg from Muppet. Ow, that hurt. So that's all we need. You might think, well, yeah, that's all well and good, but how do we get that to the graphics card? Oops. That's where the fun starts. Let's get this to the graphics card. Oh, it seems everything's stabled out now. Oh, okay. Interesting. So, let's pop this all onto our graphics card, shall we? Don't want the fragment shader now. Not interested in fragment shaders right now. Don't want that. Don't want any of this. Yeah, I think we might need some of the other stuff, like VAOs and stuff, won't we? Now, where did I put my VAO notes? VAOs, people get really muddled up with them, so I want to be doubly clear on exactly what I'm doing. I wonder if I can do it from here. I have a converter here that might be useful. Is our converter any use to me? Here we go. Alright, that's setting data up. Textures. Right, yeah. Oh. Right, okay. Gotcha. Or it's got me, depending. Interesting. Where are we putting this together? Clear screen, yeah. Got all of that. Yep, done all of that. That's interesting. What is that under? What have I done? I've done something wrong here that I don't like the look of. Where's the VAO? Here we go. VAO notes. Ask the graphics card to reserve a memory block. GL generate vertex arrays. Ah, sorry, I have to put the GEN in front of vertex arrays now. Okay. So we already have a VAO. Because that's the information we're after, isn't it? So that's the data. We are after whatever I typed in entity.h here. So I'm after, I've got the name. I haven't done anything with it, so I better do something with it. I'll just use standard technique, just put in m underscore name. Open brackets means equals, really. Name. We'll store that because I think we might need it. What is the next thing we've got here? MVAO and M index count. Okay. So that's comma. M underscore VAO. And we'll start that at 0. Comma. M underscore index count. We will start at 0. Like that. That's fine. That's excellent. So that means that is empty. And that means we can drop the equal signs. Like that. There we go. That's looking better. That's looking more like a creator. Okay. So we already have MVAO. Fantastic. I'm not going to note this up. Mainly because I'm not interested in what the data is at this point. Oh God. I twitched. Literally. So M underscore VAO equals, let's get our first piece of data that we need, shall we? What does it equal? Oh, it doesn't. It goes inside something. Oh. Okay then. The first thing we have to do is generate a VAO. There's a reason for that, a very big reason for that. It's like a macro recorder. If you know anything about macros and how to record them using like macro recorders, what you have to do is push some buttons in sequence. Well, this is what this gen vertex arrays does. There we go. All we have to do is give it the address, GL size, what? Oh, GL size, oh God, yeah. Gluint arrays. Okay. So we need one. We only want one of these. It's a star, so it's the address, and that is the address of M underscore VAO. Fantastic. We have ourselves a vertex array object, and it was as simple as that. Okay. I'm going to assume that it works because this isn't the finals. I'm doing more of a test piece, aren't I? All we need now is an index that refers to something. Alright, we generated it, so we better bind it. GL bind vertex array. That might be a good idea. Otherwise it won't know that we're using it. There we go. Thank you for that. So just bound it. I might note some of this stuff up. I don't know. See if it's any good first, shall we? I'm not certain of anything that I'm going to put here. Right, so what I'm going to have next is a GL uint. I'll just call it position, and it's going to be a vertex buffer object, or VBO. The vertex buffer object is a buffer on the graphics card that will hold all the position data, in this case. So we'll have to generate one of those, won't we? Yeah. So it's the same as before, GL gen, but this time it's vertex. That's just GL gen buffers, isn't it? Yeah, it's there. Duh. Again, one. We just want one buffer. And the name that we've given it, which will be and. Is it star? Yes, it's a star. And that is position VBO. Now, our this thing here is recording this. Yeah, it's great, isn't it? Position VBO, please. That one. That's that done. Semicolon. So we've got one of those. We'll bind it, of course, because we'll want to alter it. So GL bind. I think it's just buffers, is it? Yeah, it will be. Yeah, GL bind buffer. That'll do it. That'll get the correct one. Target and buffer. Target is a GL array buffer. Yeah, that's the target. And position VBO is the one that we're using. Now let's start sending this thing data, shall we? That's what we're after. Right, so for positions, can we send it some data? That's a very good question. We've bound it. Yeah, let's send it some data then. GL buffer data. Let's send our data up there. What's this got? It's GL enum target. Well, we know that. It's a GL array buffer. I already said that, but hey ho, you want it again, so you can have it again. GL size I pointer size. Oh. Okay. It's going to be positions. I think. Let's see if it'll do it. Dot. Okay, arrow. It's an array. What do you want? Bytes? He'll want bytes. Size of positions, which equals 16. So it's only recorded 16. Okay. And I know there's 16 numbers there because it's a 4x4 thingy. float. So that will be times the size of a float. There we go. It wants bytes. It's a size I pointer. Yeah. Now it wants the data. Now it knows the size of it. It's going to want the data, and that will be an address. Yeah, star data. So the address of the first item of data is at address positions 0. And then you want the usage. So let's give you some usage. I've lost a closing brace here somewhere. Well, because of that a lot there. Oh, it doesn't matter. Usage. Static. Static. What else do you want there? Static. Draw. Copy. Draw. Okay, we'll use that. And that's close brackets, semicolon. Okay. Does that look right? I wonder why it doesn't give me that one, but it'll give me that one. Doesn't it know the size of a float? Obviously not. Right, okay, fine, fair enough, don't care. That's all that's needed. No it's not. Shader. This is why I normally have the shader open. Color, vert. This has to match. This has to match. If I get anything in here wrong, the shader won't work. There we go, got enough space. Location equals 0. Excellent. So we need to tell it how to use it with our shader. So we've now, this has actually now put that data that's held in at positions onto the graphics card. We now need to tell it about this here, and that we want it to be used with that position there. So it can go through our shader and come out as a GL position on the graphics card. Remember, this is running on your graphics card. It's not running in here with this lot. It's running on your graphics card at a very fast rate. So let's tell it all about it. And that means we have to enable that location there. And that location there is called something. It's called a vertex attribute array. Okay. So it's an attribute. Let's do that. Let's GL enable AB LE, and it's going to be a vertex attrib array. Yeah, that one looks about safe to use. Gluint index. Well, I can tell you what it is because it says there. So it's 0. And I know it's 0 because I can see it. It's as simple as that. So really what that's saying there is which attribute we want to switch on. We are switching on that one. Remember, this is being recorded by Mr. VAO up here. So all of this is being recorded. And we want to tell it how to use our data. So we want to tell it that this data here is to go through here in a certain way. Yeah, I don't think I need a GLM for this. The GLM mass library. It's looking as though I'm not going to need it, even though I downloaded it. Oh, God. Because OpenGL's doing it all for me. So GL vertex attrib. Yeah. What we got? Format? No. Oh, we can use that one. Yeah, we can use that one. We can use the pointer. The pointer into the array here is the bit that we're going to use. So each array has a pointer on it. And we do it by putting like numbers in the brackets. That's our pointer, pointing to which item inside of the array we want to look at. Just like we did with this part here, we wanted the address of the first position, so we're using that as a pointer to that position. Well, this is a pointer that we can use with an attribute array. Exactly the same kind of thing. It just looks different. So which attribute? It's 0, obviously, comma. Size? GL int size. 4. It is, isn't it? Yeah, it's a vec4. Oh god, I can read it here. Vec4, yeah. So it's a 4. Duh. So that's how much we've got in size-wise. So it's 4 items of data. So we're using 0, 4 floats, 4 type. Well, we're going to have to tell it, aren't we? So it's going to be a GL float. So 4 floats. Yeah. So it now knows that much. Boolean normalize. Not on this one, please. We'll have a GL false. We don't want to normalize it. It's not a vector, it's a position. Yeah. If it's a vector, then we might want to normalize it and make it size 1. That just means that when it's in the shader, as a vector, it becomes nice and easy to work with, especially for our equations. We can normalize things when it's in the shader, or we can normalize on the way in. If that makes sense. Or we can pre-normalize. Yeah, never mind. Don't worry about it. GL false. So that's basically just asking us if we want to make our data size 1. Well, no we don't, because of positional vectors. Or vertices. No, positional vectors. Yeah, positional vectors as they are part of a vertex. Yes, thank you. A vertex has many different parts. It has position, it has a normal. Yeah, you get the idea. Stride. None that I can think of. No. Don't need to put one in. It's continuous data. It's a size I though. Stride, size I. The answer is size of a float times 4. But do I really need to put this in? I can just put a 0 there, can't I? Yes, I can. So I'm not going to. Size of... Because I could be lazy and put a 0 there. I'm actually going to do it properly. Float. And it's times 4. We've got 4 floats, so it's the size of a float times 4. I mean, if you put a 0 in, all it's going to do is that calculation for you. So you're going to force it to do a calculation. No, there's no point in forcing it to do a calculation. I can do it for you. I can do it for you up front. And now we want a constant void star pointer. really what that is saying is, what value do you want to initialize the pointer to? Well, none, nothing. We want it to start at the beginning, like that 0 starts at the beginning of positions. So it's a null pointer. Yep, null pointer. There you go. I'll start at the beginning. Thank you. Done. That's our vertex attributes. Nice. Nice. So we've done that far. Do we need anything else? No, not really. I want some normals next, don't I? Yeah, let's have normals next. So we're going to have to do the whole thing again, aren't we? From there. But with normals. Oh, it's not that much, is it? Alright, that's okay then. Copy. May as well. There we go. And that now becomes a normals of VBO. Because we want this recording as well. That becomes the word normals. Actually, it's easy. Yeah, normals. May as well. I'll alter it. Normals VBO. That becomes normals. Size of, I think it says normals up at the top there. Yeah, it should do. Yeah, it does. Good. Magic. Static draw. Blah, blah, blah. GL true. I do want that. Don't do that. So I don't want them normalized. Thank you. And there's only 3 of them. So it's 3 there. There you go. It's a vec3. I can see it from here. I don't need to check. So that's that done. Now what do we want? We want the colours. Oops. Twitched again. It's getting bad today, that. I might have to take a break. Okay, I do have to take a break, but hey ho. So this will be colours. I think I did plural. No, colour, colours. Oh god, did I pluralise it? Maybe plurals. No, I didn't. My god, that's unusual. Okay, colour. Oh god, I know what I've forgotten to do. Oh, copy and paste is a killer. Gen buffers, yeah. But this isn't the attribute 0, is it? It's attribute 1. So that's a 1, and that's a 1. Normals don't need anything else changing, do we? Just make sure. My cat's crying, so I might need to sort my cat out anyway. But hey ho. So colour. 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 And this is 2. Yeah, it's the last one. What do you mean there isn't one for index? Of course there isn't. Because the index doesn't get passed through here. 2, 2. And it's 4. Yeah, vec 4. Fine. Yeah, we're okay with that. Alrighty. We're cooking. We've now got position normals and colour. Data being passed into a buffer, on just transferring onto your graphics card as if nothing's going on. We hope. Okay. So we've done nearly everything now. So now we just need a GL gluint. And this is going to be, thank you Muppet for walking right across the front of the microphone there. This is index, isn't it? Yeah, it's, is it a VBO? Yeah, I suppose it is. Yeah, we'll call it a VBO. Index, vertex, buffer object. It's really just a vertex object. No, it's a buffer. It's a buffer. Okay, alright. Why has it gone yellow on me? Why have you gone yellow on me? No idea. Okay, fine. Is this just going to be the same kind of rubbish? Yeah, it is really, isn't it? So it's going to be gen. It's not the same, is it? I'll take those three. Because it hasn't got an attribute. Index VBR. Now there's something wrong here. Why is index VBO coming up like this? If I change that to IDX, is it because I called it a gluint? What did I call it up here? Not sure I understand. What is happening here? It might be a disallowed one. Don't know. Because it's not an array buffer. I think it's an index buffer. I don't know why the GL gem buffers is wrong. I've got a mistake somewhere. And I can't see it. I can see it on this one here, what I've done wrong. Because it isn't a GL, it's an element. Array. Yeah. That's right. Why is it all of a sudden gone into overdrive on red doofries? If anybody knows, let me know in chat quickly. Read it. Storage class or type specifier. I've never had a problem with GL gen buffers before. I mean, you only just... you plonker blades. Absolute plonker. Why me? Why today? It's because it wasn't in the class. Well, or whatever I'm calling this as a function. Wondered what the heck was going on there. Index VBO, index VBO, index VBO. There we go. Making bad mistakes. It's index. Size of a unsigned int. Index. I mean, it should say 6 there. Yeah, that does. That's good. Everything else is the same. Buffer data, done. That's it. We're done. And the only thing we haven't done is stored a number, which was index count, the number of indices. Ow. So we can put that at the bottom, can't we? M underscore index count equals the size of index. There you go. In this case, it equals 6. Nope. 24. What? 6. Size of index. 6. Thank you. You worked it out finally. You had me a little bit worried there. Yeah. I'm wondering if that's right or not. Should be. Alright, so that's how you create an entity. I've got green floaty thingies. Equals an unsigned long. Why are you telling me this? I don't really care. Thanks. Yeah, it's done it again here. Yeah, it's doing it with that. It's just telling me that this could be typed in a different way, I suppose. Size off is usually wrong. Really? Thank you. That's great of you, really. That is absolutely fantastic. So if we create an entity, then all we need to do is pass in that data. Yeah. Thank you for that. So here I could put GLUint, and it'll be get VAO. Const return M underscore VAO semicolon. Done. What's the next one? GL size I. Okay. GL size I, and that will be get index count. Const, and then it's open brackets, return This is how easy it is to program in C++. Wow. Index count semicolon. So I can get those two now. So what I do is I just make an entity, I run create entity, and then I just pass through those two values. So on the render, we just want those two values, don't we? So we want the shader, comma, GLUint, VAO, comma, GL size I, and that was, I'll just call it, what did I call it? That one there. Copy. Yeah. Pop you in there. There you go. You're now an index count. VAO, index count. Perfect. GL size I. Entity. GL size I. All matches up. We've got a shader. We've got an entity. We can create it. And we can pass it in. Which means we no longer have a problem here. So VAO will come from here. Sorry, render it. I haven't updated. Bad me. Bad blades. Index count. There we go. Everything is happy. That's the GL size I index count. Is that what it wanted? Yeah, that's what it wanted. So that's what it's got. That turns it off and that renders it. I wonder if that would work. What colours did we use? We didn't use any, did we? I'll have one R G B, and this last one can be 8 8 8. As near to white as I want to go. 80%. That should do it. Normals are okay. Lovely. Positions are lovely. Okay. Save that. We've got some colour. Magic. We've got arrays. VAO. And you know what I didn't do? Did I close all of this lot off? Unbind it all or not? Who's bound? Who isn't? God. Do I need to end that or not? Yeah. Do I need to end this? Really, I should, shouldn't I? That should end with the same instruction or bind that we started with. In other words, finish. So we would copy that for the vertex array. We would switch that off first. We're cleaning up basically. I need clean up here. So that's you, but that goes to a 0. In other words, you can stop recording now. That's good. And the other thing that we've got bound, is it GL buffer all the way? GL buffer, GL bind buffer, GL bind buffer. Yes, it is. Well, you can only have one buffer bound at one time. So GL bind vertex. Yeah, okay. I think we're right. I think we're very, very close now to being able to put that on screen. So it's just the binding bit. GL bind buffer is what? Oh, sorry, wrong. GL array buffer. Yeah, that's right. So it's this one. And that's all we should need. So that's the array buffer done, and that's the vertex array bind done. I think that's correct. Ah, we've got an element array going on as well here. Yeah, that can be done last. That's alright. Make sure they're all switched off. Element array, array buffer, vertex array. Alright, so that's off. That's off. In other words, if we have another model and we want to use that model and we've got all of this lot turned on, you're just heading to confusion. You are just heading to confusion. Array buffer. Array buffer. Fantastic. We're all shut down, are we? Array buffer. Yeah, we are. We're all shut down. Thank God for that. That shuts them down. So we can now return out of there quite happily. How do you put all this together? That's a good question. Wait a minute, I didn't need that strange stuff, did I? Didn't need you, after all that. We never got around to using you. Sorry, off you go. Right, so let's do a test, shall we? You can't find IO string. What on earth are you talking about? Okay. Okay. You're all mental. You're all absolutely just gone mental. You were alright before, so I don't know why you're different now. Anyway, so we've got shaders. We need to include. Some of this stuff is very strange. I mean, Microsoft. What can I say? Ah, dear. It can't even find its own functionality. Have I missed something? Any red? No red squigglies. Fine. Entity.h. You're fine. No red squigglies. It looks fine to me then. OpenGL isn't a problem. Shaders. Are you alright? Yeah, you look alright. I've been using you. Oh, why am I double checking Microsoft's stupidity? Can anybody tell me why I'm doing that? I just want to swear. Thank you. It's gone now. Yeah, what the heck was that all about? Hash include open GL, and I will have entity. It's for a test. Should move it down one. Hash include OpenGL, and we'll call that render. Right, how do we use all of this? Well, we've got our shader. All we need now is our entity. That's a test. Print there. Okay, split that line off. There we go. I'll split the U off because I want to actually get on with the real program here. Right, so we need a game, colon, OpenGL, colon, entity, and we shall call it terrain, because that's what it will be eventually, and it needs a name, so we'll call it terrain. Why not? There we go. Semicolon on that. That's all it is. Don't actually use the name at this point, but eventually we'll use the name to load up the object rather than create it. But for terrain, we'll create it in-house and save it out and then load it up. Yeah, okay. So we've got our terrain. All we need to do now is render it. Do stuff. Okay, we'll do stuff here. There is no... is that a class? Render isn't a class, is it? Please tell me it isn't. No, it isn't. Yay. So I can just say game. I'm glad I'm doing it this way. So much easier. OpenGL. Render scene. And what did it need? It needed the shader data. I think I've got that somewhere. How's about that? It needed the VAO, which is in terrain. Yeah, terrain dot is there, comma, there's your VAO, and now it wants the index count. Oh, lovely. So let's split that down. So it's readable. There we go. And that's how you do it. See if we can compile it now. If we can, I'm going to go yay and dance around the room and go and get a cup of coffee. Oh, goody, goody, goody. Did you intend to use a character count or a byte count? You cheeky buggers. Why are you asking me that? I intended to type in what I typed in, you nerds. But we'll see if it's wrong, shall we? Probably is, actually. There we go. It's wrong. Not even a black square. No colours, that's for certain. There you go. So I was right about something being slightly off. It's Microsoft. How does Microsoft get it wrong? How does Microsoft get it so wrong that it is wrong? And if it is wrong that it's wrong, does Microsoft know that it's wrong? Excellent. We're exactly where I want it to be. So what do you do when you get a blank screen? Well, there's not really much you can do. You just have to go back and say, well, what's wrong with the data? Because that's really all there is that can be wrong. I mean, the first thing that I would do straight off is go back to Entity CPP, go down to the bottom of it, and do that, leaving them all bound. And then I'd run it again. So the answer is no. That's not the answer. But we do have a shader program ID. So I don't think it's the shader. It could be. Don't think so, though. But hey-ho. So what it's complaining about is the way I've done the size of, and to be quite honest with you, I hesitated when I did it. And I hesitated because I was thinking to myself, is this going to give the right answer or not? Well. You see, I don't normally use this kind of array, I must admit. Trying to think. There's an easy way of doing this, and I know there is, but I'm trying not to go the easy route. I want to make all the noob mistakes first. So I think I've just done that. What I've done is, my sizes are alter niblets. So, my data isn't flowing. So, where do you start to debug? You don't. You just have to know what you're looking at. And I think it's trying to tell me, really. I want byte count. I think I do anyway. There is a lazy way out of this. It's funny because I made a video on this as well. I can't remember it. Okay. Do you think I should go and look at my own video and watch it and learn? Oh dear. Let's see what we've got. Let's see if I've got any notes on this. So funny. No, that's networking. That's no good to me. I did a really simple one. Let's go and find it. That's the point, isn't it? Let's just go and find the simple answer. Any ideas on stream? I mean, you're allowed to ask questions. You can ask in any language you want, as long as it's English. So that's no good. That's going to do it a different way. That's going to do it a different way. This is interesting. I've got one episode here on VAOs. I wonder if he just wants that. That's what my brain is telling me. I think I've gone too far with that calculation. We'll see. GL buffer data, isn't it? Yeah. I'll look it up. I hate using buffers like this. This is a reason I don't normally do this as a tutorial. It's because I hate this. Doesn't mean much to me. Stop the complaints, I hope. Yeah, that's stop the complaints. Nothing on screen yet. Okay. I was sure that it was in bytes last time I looked. But hey ho. Oh, right, that's up here, is it? Whoops. GL buffer data. See, you can tell I've looked at it before. GL named buffer data. Buffer binary size specifies the size in bytes of the buffer object's new data store. It's in bytes. I was right. So, I don't understand that. That is really, really a bit weird. That's the correct number. Because I know there's 6 of them. He doesn't seem to complain about me doing that. That's interesting. So size of colour is 16, isn't it? So size of a float times 16. It's called a test model, so I don't care. It's not coming up with silly notes this time. How weird. God, if I understood Microsoft, that'd be brilliant. There's only 12 of these. And normals are floats. And then I've got to check my data. I might change my data set actually. Those are all alright. I did ask me normals to be normalised, didn't I? Wait a minute. Did I copy that over? So colour, did I normalise it by accident? GL faults, okay. Nothing to do on there. Yeah, that's right. Yeah, okay. GL float, false, good. GL true, GL false. Right, so the data's correct. Data size is correct. Okay. What should we put out? We shall put out what are we looking at now? Entity VAO. I'll just put equals. And it's %D. May as well look at it and have a quick gander to see what it is. It's terrain.get VAO. Thank you. That's that one. I should really put other things in, but using the debugger, as everybody says, but when it's 2 items that I'm after, I don't usually do it. I'll just put a printf statement in. And this one is entity index count equals %D. To put \n in. And then that's comma terrain dot get index count. Will do nicely. That'll tell me if I'm right or not. Non-standard syntax. It is, you're right. Sorry, my bad. Run. you go. There's a problem. They're at 0. So why are those two items at 0? We're passing zeros through, so it is doing exactly what we've told it to. That to me is quite interesting. Oh, I know why it doesn't do anything. Because I'm an idiot. I've not asked it to do anything, have I? Oh, Blades, you haven't done the classic goober thing. Yeah, great, you've made the entity, but you haven't used the function. For God's sake. Try doing that, maybe? Okay, have we got an entity now? Yay! We have a VAO and an index count. Yes! We are there. We are there at long last. Fantastic. Right, so we've got our entity. First part works. So we've got 24 as the index count, which is wrong. Isn't it? No, the index count certainly isn't that big. I mean, I can count them here. It's 1, 2, 3, 4, 5, 6. So how are you getting 24, mate? Because it's often wrong. I'm just going to put the number in. Stuff it. I don't care. So it should be 1 and 6. Right, that's better. 1 and 6. So our index count is now 6. That's great stuff. And that means everything's working. Fantastic. All we need now is a shutdown for that, because I'm now flooding my graphics card with data, which it doesn't really want to keep. So all of this has to go. How shall I get rid of it? Or what do I need to get rid of it? That's more the primary. I'm not bothered about whether it displays on the screen or not. That's immaterial. I can fix that anytime. Just by doing it right. Might help. I will need a shutdown in entity. Right, let's get this sorted so that it can't be wrong. Right, the first thing is that is no longer empty. That is now create entity. That's the first thing. We have to do it that way because it's a test situation, which takes that line out. Now it's right. Thank you. And I know it is, so we're alright. That will now create the entity, which means now I can destroy it. Fantastic. So what do we need for destroying? We need all of the numbers. We need all the buffers, don't we? So every single one of these buffers. Yeah, we do. they're all gluints, aren't they? Still can't spell gluint. So we've got positions. Position. VBO. I'll just call it that for now. Comma. Yeah, I'm not liking this. Normal. VBO. Comma. Color. VBO. Comma. Index VBO. So, what have I done? I've made them all into member variables. That line gets destroyed. That line gets destroyed. That line gets destroyed. That line gets destroyed. And now it hates me. Index VBO. Okay, that's better. Come on, catch up with me. Never mind. Okay there. Yeah, we're okay there. Happy. And these should all go into a white colour. Yes, they do. That's good, that's good, that's good. That's fantastic. We're getting there. Now what's wrong with that? Oh, right. I haven't initialised them. Oh, you joke me. You joke me not. Comma. Yep. Position VBO starts at 0. Normals. It's a shame that I'm going to be turning this into something completely different in like the next episode or two. VBO can start at 0. The colour VBO can start at 0. And the index VBO can start at 0. Thank you. Right, you can go away with this little green squiggly now. Thank you. Horrible thing. Yeah, that's right. Here we go. This is going to be fun. GL delete buffers. Here we go. GL delete buffers. And it's going to be 1, index VBO. Yeah. Right, let's get this set up properly here. And here. Why can't you do that? because you want a pointer. You don't know where it is. Great. There we go. Yeah. Copy. And that's going to be, read them back up, that's colour next. I always do them in reverse. Next one is normals. And the last one is position. This is what you have to do to complete an OpenGL test. I don't believe it. GL, and it's going to be delete vertex arrays. Yep, that's okay. You can obviously do them all at once, which is probably what I will do in the final thing, but for now it's just going to have to be underscore VAR. That'll have to do. Name's okay and count is okay. Yeah, we're alright with the rest. And again, it's the address. There we go. So we've now got a nice little block of deletes. Yes, folks, this is the kind of thing you have to do to get OpenGL to work properly. But now at least we've got it in, which is good. Create entity is automatic. We're getting the right details out of create entity. So the only thing that's wrong now is our render. And our render is taking in the correct stuff. I'm not happy about that. Yeah, I am. Because I've now set it to 6, which is correct. The VAO is coming in, it's number 1. Does GL draw elements need something different? Not that I can see. I mean, that's usually just 0, but null pointer will do a 0. Doesn't even tell me what it is. That's charming, isn't it? This system doesn't even know what its own null pointer is. That's good. And we switch off there. Okay. There we go. And that's the end of that, I guess. What are we on now? Yeah, 3 hours 34. Yeah. So what I'm going to do is go and fix it, I suppose. In other words, I'm onto little clickety red buttons on the side. I don't even know if we're rendering properly at this stage. So render. Do stuff. Render scene. Swaps. Yeah. Yep, that's okay. As long as the class, it'll do it itself. Interesting. I mean, I would expect it to spew out errors at this point, but this has been done to me before by Microsoft stuff, so I'm going to go and get my OpenGL error checker. Yeah, I can do that, can't I? Because that's correct. I don't care what I'm seeing on screen, and what's on screen is irrelevant to what I'm seeing here. I mean, I haven't even switched the lights on. So whether it's working or not, I have no idea. I would have thought so. Oh, we don't have a perspective. Bugger. No, it's not working. It's not working because we don't even have a perspective. Blades. What have you just rendered to? You just rendered to a 2D screen without perspective. So where is everything? Everything is at 0. I don't know if we need the ones. But it's all at 0. Oh my god. Oh my god. Right, let's try square. Plus 0.5, plus 0.5. Oh god, I just realised what I've done. That was clever of me. Of course, it can't see that as minuses. So that's your top right hand corner. I want to go across to the left, which is a plus and a minus. Minus 0.5. That's half the screen, by the way. Half the screen width. Oh, for god damn it. Then we want to go down to the bottom, so that's a minus. That follows 5. And that goes to, yeah, that's correct. And the last one is the bottom right hand corner, which is, oh god, I'm getting too many spaces going here. 0.5 again, x, and that's on a minus. So the last two are minus point. Yep, that's right. Okay. Z is 0. We haven't got any perspective. Don't think the last number matters. There you go, done. It was my fault. I thought we had perspective. I was thinking in 3D instead of 2D, which I should have been doing. So that's what we've got. I've got my coloured Dubry. And as I said, I went top right, top left, bottom right. You can check that here just behind the colours. That's entity.h. Darn it. Fair enough. Oh, I've now got a call. Okay, bear with me, I just got a call. Hello? Hiya. Hiya, love. How's it going? Not bad. I've just completed the first part of the stream. We've got something on screen now. A square with pretty colours.
Cats?
Not doing too badly. The cats are doing very well. The cats are doing very well.
Oh, good. Well, yeah, they usually do, because they usually get their own way, so why wouldn't they?
Yeah, that's true.
Any visitors?
No. With your stuff got dropped off. So we've got your meds got dropped off.
Oh, good, that's great.
So that's been done.
I'm hoping that it'll be sorted when I get home.
Yeah.
Because they had to get some extras, but if not, I'll sort it.
Right.
Back. It's not a big deal. Anything else arrived?
No. I think I'm on the finals now, so I'm heading into my wrap up for today's work.
You're on?
I'm just starting into the wrap up now for today's work.
Okay.
So.
Well, we've just been out for sort of
Yeah.
darts match.
All right. Okay.
So the teams, so I'm not getting involved with that. So I've got a chill night.
Yeah.
So yeah, that'll be good. Lee's been working from home today,
Mm.
and he'll be working from home on Friday, which is when Mel and Tony should be picking me up, but I'm not sure what time.
Right.
We're
Right.
probably looking at
Okay.
early evening.
Yeah, I will have to cut you short, love. Sorry.
Sorry?
I'm gonna have to cut you short. I need to finish my work here. I'm streaming.
Right. I cancelled the cleaning lady tomorrow,
Okay.
primarily because it wasn't Kim, it wasn't Cheryl, it's a lady that you don't really know, and I just thought,
No, that's fine. That's fine. Okay.
you're alright though.
Absolutely. Yeah. Yeah. I just want to get on with doing this, please. That's all.
Okie doke. Well, like I say, I'd just like to keep in touch with you, know that you're all alright and everything.
Oops. Spilling things now.
Sorry?
Spilling things now. Yeah. Okay. So I'll catch you later. All right.
Alright, okay.
All right.
You make sure you get fed and get your sleep and stuff.
Certainly will.
Big
Certainly
hug.
will.
Alright.
All right then, love.
See you soon.
Take care.
Alright. Night. Night.
Ah, dear. I don't know. Oh, spilling stuff. Yeah, what I wanted to say was the corresponding 0, 1, 2, 3, 4 was 0, 1, 2, 0, 1, 2, 3. Sorry, not 4. Oh, God, she's put me off. So that's red, RGB, RGB, and I put a low white in the bottom one, just because it doesn't look good if you put bright white in there. But you can also see how all the colours will intermingle and flow between each other. That's called interpolation, where it will interpolate between two colours. Halfway along that line, the colours are at equal strength. So somewhere in that orangey bit there, just there somewhere. And it's the same here, but it doesn't look it on the bottom one because it's, there you go. The blue to green and the green to red work, and the red to white work, and the blue to white work. So the edges do work. It's okay. That's looking good. I'm rather happy. So it's all worked out. It was just me putting garbage, 3-dimensional data into a 2-dimensional renderer. Typical of me. But hey ho. What I'm going to do now is I'm going to get off. We're going to turn this into a 3D renderer next. So I will need GLM. But I'll also be looking more at this entity, and the reason why it isn't noted up is quite simple. Why I haven't explained it fully is because I don't want this here. This isn't what I want to do with my entity. And it's also a bit messy, but it does work and it will destroy everything properly, which is what I wanted for now. Right, so next up will be render. Oh yeah, we've got to introduce, so we've now got to render terrain in 3D. And then we can put the lighting on, and then I can sort my lighting out, and then we can get the entities and everything sorted out. And that means we'll be having open entity season with lights, cameras, and action. That's hopefully coming up rather soon. Rather sooner than people think. So I'm going to go and have a look at this stream and why it's been messing me about. And in the meantime, I would like you all to take care. Enjoy yourselves. And of course, have fun.